Imagine something deep inside our galaxy, about 15,000 light-years away, sending a powerful signal straight toward Earth. Every 44 minutes, like clockwork. Not once, not randomly, but again, and again, and again. Scientists don't know what it is. They don't know why it's pulsing, and some say it shouldn't even exist at all. Welcome back to the channel, where we explore the strangest mysteries of our universe. If you love space, science, and questions that don't have easy answers, you're in exactly the right place. Make sure you subscribe, hit the like button, and turn on notifications, because today's mystery is truly cosmic. Now, let's start with the basics. Deep in the vast darkness of our Milky Way galaxy, astronomers recently discovered something completely unexpected. An object now known as ASKAP J1832-0911. At first glance, it doesn't look special at all. No glowing nebula, no massive explosion, no dramatic supernova. But then, scientists notice something strange. This object sends out powerful bursts of radio waves, each lasting about 2 minutes, and it does this every 44 minutes with eerie precision. That alone would be unusual. But what truly shocked scientists was that the same object was also emitting X-rays at the exact same time. That had never been seen before. The discovery that stunned astronomers. The discovery began quietly, as many of the greatest scientific discoveries do. Radio astronomers using the Australian Square Kilometre Array Pathfinder, or ASKAP, were scanning the sky for unusual radio signals. ASKAP is built for moments like this. It monitors huge sections of the sky, searching for brief signals that blink on and then vanish. And that's when ASKAP J1832-0911 appeared. A pulse, then silence. Then, exactly 44 minutes later, another pulse. At first, researchers thought it might be a glitch, or interference, or maybe a known object behaving in a strange way. But the signal didn't stop. It kept repeating. So astronomers turned to another powerful observatory, NASA's Chandra X-ray Observatory. When Chandra examined the same region of space, it detected something incredible. Every time the radio pulse appeared, X-rays appeared too, perfectly synchronized. Why this changed everything? This wasn't just unusual, it was historic. ASKAP J1832-0911 became the first known long-period transient, or LPT, ever observed emitting both radio waves and X-rays. To understand why this matters, we need to talk about time. Most known cosmic objects that pulse, like pulsars, spin incredibly fast. Some rotate hundreds of times per second. Even magnetars, or the most extreme neutron stars in the universe, usually pulse every few seconds. But this object, once every 44 minutes. That's not slow. That's absurdly slow by astrophysical standards. So slow, in fact, that according to existing models, it shouldn't be able to produce strong radiation at all. Yet here it was, doing exactly that. Where is this thing? ASKAP J1832-0911 is located about 15,000 light-years from Earth, deep within our galaxy. That means the signal we're detecting today left this object 15,000 years ago, back when early humans were still painting images on cave walls. Whatever this object is, it's ancient, and whatever process is powering it has remained stable for an incredibly long time, and that only deepens the mystery. Theory 1. A magnetar? The first explanation scientists considered was a magnetar. Magnetars are neutron stars, the collapsed cores of massive stars, with magnetic fields trillions of times stronger than Earth's. They are some of the most violent objects in the universe. Starquakes, gamma-ray flares, X-ray bursts, and yes, magnetars can absolutely produce radio waves and X-rays. So, mystery solved? Not quite. Here's the problem. Magnetars spin fast. Even the slowest known magnetars rotate in seconds, not minutes. To pulse every 44 minutes, a magnetar would need to slow down far beyond what current physics allows, without falling apart or going completely dark. Some scientists propose the idea of an ultra-long period magnetar, but there's no confirmed evidence that such an object can actually exist. As one researcher put it, if this is a magnetar, it's unlike any magnetar we've ever seen. Theory 2, a magnetized white dwarf. Next, scientists looked at another possibility, a white dwarf. White dwarfs are the remnants of stars like our sun, dense Earth-sized objects left behind after a star runs out of fuel. Some white dwarfs are highly magnetized, and some rotate slowly enough to match a 44-minute period. At first, this explanation seemed promising, but then came the energy problem. White dwarfs simply don't have enough power to generate such intense radio bursts and X-rays on their own. To make the math work, the white dwarf would need conditions far beyond anything ever observed. Once again, scientists reached the same conclusion. This doesn't quite fit. Why known physics falls short? And this is where the mystery becomes truly fascinating. Every explanation we currently have requires bending the rules. Either the object is too slow to be a magnetar or too weak to be a white dwarf. Yet it behaves like something far more energetic. In scientific papers, researchers used unusually strong language. Phrases like challenges existing models, difficult to explain, defies conventional understanding. In science, those words matter. They mean one thing: we don't know. Why this discovery matters. So why does any of this matter? Because discoveries like this change science forever. Every major breakthrough begins with something that doesn't make sense. Pulsars were once mistaken for alien signals. Black holes were once considered mathematical fiction. Even X-rays themselves were discovered by accident. ASKAP J1832-0911 could represent a completely new class of stellar object, a missing stage in stellar evolution, or physics we haven't discovered yet. And this is likely just the beginning. As telescopes become more sensitive, scientists expect to find many more long-period transients hiding across the galaxy. This one just happened to be the first and the strangest. What happens next? Astronomers are now watching this object closely. Every pulse, every fluctuation, every anomaly. Future observatories, like the Square Kilometer Array, will be able to detect even fainter signals and map these objects across the universe. Each new discovery will help answer one critical question. Is ASKAP J1832-0911 truly unique? Or is it just the first example of something much bigger? Final thoughts. So now I'll ask you, what do you think? Is ASKAP J1832-0911 a bizarre magnetar, a strange white dwarf, a glimpse of entirely new physics, or something we haven't even imagined yet? Share your thoughts in the comments. I read every single one. If you enjoyed this mystery, like the video, subscribe, and watch the next cosmic mystery on your screen right now. Thanks for watching, and as always, stay curious.